So thank you so much for the kind introduction and welcome to the audience. Thank you for being here at this great event that's showcasing what women in technology are actually doing. Thank you. So, as I said, as introduced, the title of my thesis is Scalable Business Process Execution in the Cloud. That's actually just a shortened title of my thesis, which was a bit longer. And for the thesis, I received a Best Thesis Award from the Computer Science Institute of Vienna last year, which I was very honored to receive. And I was asked to give a science talk here today about what I did during my research. So I know that the topic is a bit hard, so I tried to simplify it a lot. I use a lot of analogies, so I'm pretty sure everyone is going to be able to follow along. So to start with, I will tell you a bit about myself. And I believe that events like this one are a great way to provide a role model or to show young girls and women how they can actually approach a career in tech. And first I would like to start with what I think are the main drivers of success of everyone. So I have developed my own little theory. I'm still very young, so this might change over time, but I think in general you have to work really hard and be ambitious, so you have to set high goals. As you can see, everyone who has done something that you're really amazed of, you can be pretty sure that they did a lot in the background also if you don't see it. Secondly, you have to take risks and step out of your comfort zone. So the thing is, every time when I had the feeling that I'm doing something that really helped me grow as a person or where I really had an impact, it was something where at the beginning I was very scared and afraid to do it because I didn't have the expertise, the experience, but it's only when you kind of step out of your comfort zone that you can really grow. You have to be passionate about what you do and stay curious. I think that's a no-brainer. You gotta love what you do. And you have to stay focused, and I think this is actually one of the harder parts in today's, I call it society of distractions. And what I also like to say is that you have to be there with always a telescope on one eye and a microscope on the other eye, because you have to really stay focused on what you're doing and what it is that you're currently working on, but also always have this sight for the future and just make sure that what you're doing actually also has an impact regarding all the changing circumstances. So I had the privilege to work on my thesis at Data 61, which is a leading research center in Australia. I lived close to the Allianz Stadium in Sydney, and whenever I went for a run, I ran past this poster, which I really liked, and it kind of remembered me of all the people that supported me. And it says, behind every story of success is an even greater story of support, and I believe that this is so true. And I think that mentors are the ones that make you. They can also break you, so you kind of have to find the right ones. And I don't just mean the mentorship I received on the job for things I did or tasks I accomplished, but also the mentors that I had from a very early age on, the ones that kind of provided me with support to go for what I actually wanted to do. And being in tech, I'd say, is pretty a desirable thing. So I ask myself today, why am I here? Why am I in tech? And why are so many of the female friends I had as a child not in tech? So, and I personally believe that having the right sponsors that push you to pursue things is like the main driver. So I would actually go so far as to say that this stage here is actually just the side stage, and the actual main stage today is in the seminar room where we're teaching children how to think like scientists and to get interested in technologies. And also children in general, also girls and also boys, so that's like the main thing. So I started, when I thought about this talk, I started like my research on Google image search. And I wanted to know what Google thinks are toys for girls, and that was Google's result. So what I saw there's a little girl standing in a pink plastic kitchen, preparing some game of cooking, I guess, and then there are makeup games and being pretty things, and there's like also this baby doll, which I find really funny because it's like you trying to teach girls to take care of children in such an early age. And there was this book from Sheryl Sandberg, Lean In, I think most people have heard of it, and there she says that women shouldn't leave before they leave, so it's like when they are in a career, they shouldn't just step back and get out of the things they want to pursue just because they think that in a couple of years they want to have children. And I feel like with those games we're maybe sometimes making little girls get out before they ever had the chance to get in. So next what I did is I Googled what are toys for boys, and then I got this, and to be honest it's a bit shocking because what I see here is like the girls are playing with toys that enhance like their household and cooking and childcare abilities, while the boys are given those strong, independent action figures and superheroes with cool capabilities. They're given those Lego toys where they learn how to build cool cars to make those superheroes even faster and better. And they kind of get a lot of guns. I don't want to comment on that. Maybe it's like the dominant side that should be developed. And so depending on your gender, the society has this picture of you, and it's maybe it doesn't happen because people want to push you in a direction, but it happens from your surrounding often, that you get like toys from friends and parents and that push you in a certain direction that maybe was never what you really wanted to do. So I personally, as a child, I preferred blue over pink, and the thing is, there was a time, actually, when you look at the date, it's 125 years ago, it was in the New York Times that you should always give pink to a boy and blue to a girl. So it's like, it's nothing that's set in stone or that should define us as women, what society currently says we should do. So, as a child, I had the kind of inner conflict that I liked playing with the toys for boys, and I had no girlfriends that I could play with, so I was pretty sure that I'm a boy. Then it took some time. At some point I got this as a present, which I kind of liked because she was ambitious. She was like the Olympic Barbie that did compete in competitive stuff. She has a gold medal, and I was like, yeah, maybe I can be like a girl. And so then I always was into math, so I went into a Scalable, it's called in German, which is like a scientific school. Then I saw that I'm interested in both business as well as computers, so I went into an IT commercial high school. And I always did like a couple of internships. Which I very much liked is that I tried to travel a bit, so I also did an internship in China. Then I did an internship in Albania, which is the place where I'm from, so I always kind of tried to combine working, doing something, and seeing something. And after some time, I kind of had this natural progression to come to the TU and study business informatics. And after the first few semesters, I also started working as an IT project manager and as a study assistant here at university. As a project manager, I started with doing like internal projects at the beginning, and afterwards I kind of stepped out of my comfort zone. That's like the moments where I grew the most, and the biggest project that I did was a research and development project where I managed to set up the funding, and we did in cooperation with a company from the automation industry some analytical processes for manufacturing. And well, after some times, I had to find like what I will work for on my master's. So I decided to go to my supervisor based on the fact that he was working on Industry 4.0, and I was apparently very much into it because of the work I was doing. At the end of the day, my work is pretty generic, so you can use it for Industry 4.0 scenarios, but also for any other scenarios. And I was lucky to have the opportunity to go to Sydney for my work. I went to CSIRO, to the group Data 61, as a visiting student researcher. And of course, Sydney is in and of itself a very nice place to be, I have to admit, but it was also such a great, inspiring place to just see how researchers in a very different culture think differently and work differently, and to be like integrated into this field where you could work together with PhD students and researchers from various fields. And I honestly liked it. So now let's look at what I did there. So generally speaking, I have performed research in the areas of cloud computing and process management and operations research. So let me start with a little thought experiment. Imagine you're driving home in your car. Your dog might be with you and you just want to arrive home as quickly and safely as possible. On your way home, your car automatically transmits data to your car manufacturer, who provides you with a couple of smart services. Your navigation system, for example, automatically suggests the best route based on the current traffic situation. At the same time, the system detects that you're overdue for a repair check and tries to find a suitable schedule with your mechanic. And as soon as you arrive home, your insurance app tells you that due to your good recent driving style, your insurance score performed. So what's actually behind all of this? The foundation for all of these examples is that they essentially run different types of analytical processes in the backend. As such, process landscapes are often very volatile, and the number of resources you need to compute the load is very hard to predict. These processes benefit from being executed on a scalable cloud environment. So computational resources are valuable and scarce, so we want to optimize them. So we're generally looking at a large set of complex processes. Each is composed of different steps and tasks. Some of the processes need to be executed immediately, while others can also be postponed into the future. More specifically, we're looking at elastic processes, meaning processes that can also be executed on a scalable cloud environment. In my thesis, I make use of the vertical and horizontal scaling properties of cloud computing. So vertical scaling in general refers to scaling the number of utilized resources on one single node up and down, like increasing the memory from 4 to 8 gigs. And horizontal scaling refers to changing the number of different utilized nodes. So now, what are those nodes that we're scaling here? In classical cloud computing, you're always looking at virtual machines. It's like machines that run on physical machines in a server environment. And here I also take another layer of abstraction and also look at using containers. So what are containers? I guess most people might have a picture like this in mind, and this is actually pretty accurate, and I'll try to explain the rest of it with those containers. So let's take a quick look at the main differences between VMs, virtual machines, and containers in the context of virtualization. So virtual machines are in general very heavyweight. They include a full operating system with its own kernel. Containers also offer you the means of running applications in isolation. But they don't, they just use the host's operating system, therefore they are pretty lightweight. I use Docker containers, which maybe some of you might be familiar with. So by analogy, VMs can be seen as the heavyweight ship, and Docker containers can be seen as those lightweight containers that also offer you a means to transport your cargo from A to B, but without possessing all the heavy features of a real ship. So let's take the ship analogy a bit further. Imagine you have a ship and you want to transport two chemicals, both in need of their own special environment. The ship is large enough for both chemicals, but if you don't use containers and just throw them into that one bin that you have, you might end up in a pretty explosive situation. So to avoid this, you basically have two options. Either you rent a second ship for a set amount of time, or you use the same ship and isolate your chemicals into two separate, highly flexible and easy to handle containers. The same thinking goes for different software services. So it's often a very important requirement to run services in isolation so they don't get in each other's way. So if you use the solution on the left with two separate ships, it would be like two different virtual machines. And this is basically the approach that previous research used. In my thesis, I was focusing on the solution on the right, meaning encapsulating the services in different containers and allowing a more flexible and fine-grained scheduling approach. So this looks pretty easy here, but the problem is that defining this is way more complex, and so you have this additional layer of complexity to find a solution. So in the example with multiple ships, we also especially see that a ship or a virtual machine is only dedicated to one type of service or cargo at one time. And for example, when the red cargo reaches its destination and we need to handle some new type of cargo, we either have to lease a new ship that is capable of doing so, we have to somehow transform the old one to be capable of doing it. And now with containers, we can easily take that one type of ship and load different types of containers on it. So we can easily also replace or resize the containers. And now imagine we're not talking about just 3 ships, but an ocean of ships and containers. So to run a fluctuating number of different processes in the cloud, we developed a management system. We designed, the system considers quality of service constraints. We especially look at deadline violations. And we have a reasoner component that takes all the incoming requests, performs the scheduling, and the reasoner's result is then executed on a container-based cloud environment. This system carries out what we have defined as a 4-fold autoscaling, meaning it performs both the vertical scaling as well as the horizontal scaling on both the level of virtual machines as well as the level of containers. And so mainly the reasoner calculates a resource allocation and scheduling plan that consists of 3 parts. It decides which VMs to lease for how long, what container instances with which configuration to schedule on which VMs, and what process steps to schedule on which container instances. The problem is defined as a mixed integer linear programming optimization model. I implemented it using Java ILP and solved it using a commercial solver, namely IBM Cplex. So the mentioned mill problem has an objective function that basically looks like this, and this objective function is also subject to 28 more constraints. Yes, I know, that's a lot. No worries, I'm not planning to go through this now, but I just want to go quickly through the main objectives that we want to solve in this objective function. So the first 2 are like the most important ones. The first term aims at minimizing the total costs for leasing virtual machines. So we consider different virtual machine types in different cloud environments with various CPU and RAM resources, and VMs can be leased for 1 or also multiple BTUs. The second term aims at minimizing the penalty costs that arise for every time unit that the process execution is over the defined deadline. We also minimize the time needed to deploy containers on virtual machines by preferring virtual machines where like the image for creating a container has already been pulled. It's like it has already been installed, you can say. To maximize the future resource supply of the already leased VMs, we also try to prefer the VMs with a smaller remaining leasing duration if the other terms don't hold. And we also minimize the free lease but unused resources to basically not waste any resources. And the last term mainly makes sure that processes with closer deadlines receive a higher priority. So we performed very extensive experimental evaluations under various configurations. As just one example, here is the result for constant process request arrivals with strict deadlines. So the red line is the process arrivals, the blue line is our solution and shows the number of leased CPU cores over time. As a baseline, we used the only virtual machine-based approach proposed by previous research that solved the problem using a mixed integer linear programming optimization model. And when looking at the total costs, we can see that our approach is nearly 3 times more cost efficient while still having very strong SLA adherence. And here's another sample chart with pyramid-like arrival of process requests, and again our approach shows substantial cost savings and better resource utilization when compared to the baseline. So let me sum this up. What did we do? We developed a management system for the optimized execution of elastic processes that performs this fourfold auto-scaling, meaning vertical and horizontal scaling, on the level of both VMs as well as containers. And why? We did it to achieve a more dynamic resource utilization by using container technologies and therefore reduce costs for cloud-based execution of, while considering quality of service constraints. And how? We developed a mixed integer linear programming optimization model that calculates this optimized allocation. And we designed a management system for this container-based execution. And the results, compared to the VM-based approaches from previous research, we were able to at least cut costs in half or even perform better, as shown in the previous charts. And this while maintaining pretty high SLA adherence. So I want to finish this talk by taking a very quick look into the future and emphasize why I believe that working in tech is something that everyone should aspire for, and why it's probably one of the most interesting career paths, but I might be biased. So to get this bias out, I looked at what McKinsey is saying, and they have defined the 4 main global forces which they say will have a huge impact on our future. And they're saying that we're living in a time of great change, and one of the main forces is that we are in a kind of economic power shift where things are going towards Asia, and that is happening pretty fast currently. As just an example, it's estimated that 2.4 billion new middle-class consumers will be in the world by 2030, and 2 billion of those will just be in Asia. So it's definitely a market that we should all consider, and when building new solutions, we should take this into consideration because there's a huge potential there. Secondly, they say that technology is moving at an incredibly fast pace. So the change in computing power, when looking at the connectedness of people and things and the data we produce and all the applications of those things, it's kind of changing our whole life gradually. And from connected cities to medicine, you can find so many areas of application. So also if you say, I don't want to be a developer, or I'm not into tech because X, Y, Z, there are so many other areas where you just will have to use tech. So being tech savvy will help you in a lot of areas, whatever your interests are. The third thing is that in general, and especially in the West, we're having an aging population. So this has tremendous implications when looking at the GDP of Western countries compared to what the GDP of Asian countries will be, where the population will be younger. So these are things that we have to take into consideration. And lastly, the question is, who are the people who will profit from these developments and who are the people who will kind of lose out, and what do we do about it? And so we might have to change like the societal norms and dogmas that we're currently following, and I believe that people with a technology background will be extremely important to also think about those things. And also, for example, only if you go to politics and see how new rules and regulations are made. I believe that as technology is all around us, we also need people with a solid technical background to be there. So I think that technology is expanding more and more, and it will be much more than people currently think it is. So it's definitely something everyone should look into. And there's a quote which I really like, which says, "We have created a Star Wars civilization with Stone Age emotions, medieval institutions, and godlike technology." So I believe we have to create this like inclusiveness and include women and men and people from other countries and religions and everything to build this new society that is built up on technology. And we have to kind of get used to the idea of lifelong learning, I guess. I don't believe that there will be such a thing like going to university for 4 or 5 years and then stepping out and never returning back. I think we all will have to go back and learn more sometimes, especially as we're aging more, and reskilling of people will be a big issue. And innovation, of course, is what's going to drive this. I just wanted to mention the term frugal innovation, which thinks of scarcity, because we're in the West often think that we develop solutions for scenarios where we already have everything, and we just try to develop new things. But there are, especially in these emerging countries, situations where people just have to deal with the scarcity and still be innovative. And that's, I think we will be able to learn a lot also from what will happen there. So thank you very much for your attention. If you want to connect, please do so, or write me an email if there are any questions, and thanks.